Hello and welcome everyone to my channel Code with Ease. So as part of the binary search series, today we are going to start with the questions related to binary search. So today we'll discuss about this question of finding a square root of a number but using binary search. Finding a square root of a number can be done in many different ways, but why do we want to apply binary search to this? Because we want to improve the time complexity of finding this. So given a non-negative integer x, we have to compute and return the square root of that number. Since the return type is an integer, decimal digits are truncated and only the integer part has to be returned, and we are not allowed to use any built-in function. So it's very simple in case of perfect square because we can have an integer only as its square root. The problem is when the number is not a perfect square, then in that case what would be the square root? So as it is given here 8. The output is given 2. What is the nearest perfect square near 8? 9. 3 square is 9. But the output is 2. Why? Because whenever we are trying to compute the square root of any number which is not a perfect square, we always take the floor of that, like the lower number. Like we are not supposed to return 3 here because 3 square is 9. So what is lesser than 3? The next integer after lower than 3 is 2. That is why we are supposed to return 2. So this is one key concept which we have to remember, that if we have to find out the square root of a number, we'll always consider the floor. There are two concepts in maths, floor and ceiling. So floor is like the less than equal to of that number, the lower bound, and ceiling is the upper bound, like greater than equal to of that number. So in this case, we are always supposed to consider the floor of a number. So with that being said, now let's move to the whiteboard to understand quickly the approach for solving this question. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic-wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. So before even we apply binary search to find the square root of a number, let's understand from a brute force way, what is the initial thought process? How do we calculate a square root? So we'll start from 1. So we'll say whether 1 square is greater than x. Let x be the number for which we have to find out the square root. Then we'll similarly do it for 2 square, whether this is greater than x, and we'll do it all the way. 3 square, 9, is it greater than 12? No, it is not. 4 square, 16, which is actually greater than 12. It is true. But we need one number lesser than that. We need the floor of this. So 4 minus 1. So whatever the number we are at, I minus 1th number will be our required square root. So this is how we can find out the square root by traversing from 1 to whatever the number we are given, the x. So there is an important observation over here that I want to bring up. Square root of a number, be it any number of a number, will never be greater than the mid of that number. Let's take a simple example. 25. 25 square root is 5. 16 square root is 4. Like with the previous example, 12 square root is 3. What is the midpoint of this number? 12 divided by 2 is somewhere 12.5. 16 divided by 2 is 8. And 12 divided by 2 is 6. Is the square root of the number anytime greater than the middle of the number? No, it is always lesser than the middle of the number. So if at all I have to find out a square root, why do I need to traverse from 1 to x? I will traverse from 1 to x by 2, halfway, because in that half only my square root, if at all it has to lie, it will lie in that range only. Okay, so that is one observation. So on this only we will apply the binary search. Now our search space is reduced to half firstly, and then from that half we have to do whatever calculation we need to find out the square root. So for binary search, we use these 3 pointers: start, end, and mid. We find out the midpoint. So initially now we can set our start to 1 and we can have our end to x by 2, the middle point. And then we can have our while loop, which is going to run from start till the end. Within this, we will calculate the mid, like we told earlier, how we calculate start plus end minus start by 2. So once we get the mid, now we have 3 conditions for us. First of all, what is this mid? Mid is the potential square root. So we'll do mid into mid. And then we have to check whether this is exactly equal to the number itself. If that is the case, then we can return this, because that is what our square root is. When will this happen? When x will be a perfect square, which is the ideal scenario. What if mid into mid is lesser than x, like we were discussing over here? 2 square, 3 square, these were all lesser than x. In that case, we'll also have another variable or answer variable. We'll store this mid, and this start pointer, whatever we have, will make this equal to mid plus 1. Why are we doing this? We mentioned that we would need the floor value of a number in order to be a square root. Like if the value lies between 3 and 4 square, like 9 and 16, if any value lies between 9 and 16, 9 is a perfect square, 16 is also a perfect square. If any value lies between 9 and 16, the square root of 9, that number has to be 3 and not 4, because we are taking the floor. So we are storing this value thinking that this mid, whatever this mid is, this also could be a potential square root for x. And then we are moving ahead. Why we are moving ahead? Because what if there is a new mid which is still lesser than x? In that case, this answer will get updated. So in this case, what happened? 4 is also lesser than 12 and 9 is also lesser than 12. When we came across 4, then 2 is also potential, could be a potential square root of 12. But when we got 3, we determined that 3 is greater. So 3 is a more potential square root of 12 than 2. So that is why we are storing the answer and then we are going forward. And finally, what are we left with if mid into mid is greater than x? So if it is greater than x, we will always want to go one step lesser. So we'll do end equal to mid minus 1. So that is the approach for finding a square root of a number using binary search. So these are the 3 conditions. So that's all for the approach of finding a square root using binary search. Now let's write the code for this. Okay, so we'll start with the code changes. So this is the given input to us. So first of all, let's talk of the edge case. If the value of x is less than 2, then we can return x itself. Otherwise, now we're going to apply the binary search. First of all, we'll define the pointers. We'll start from 1 and we are going to end at x by 2 and we'll calculate the mid. Now we'll start with the while loop. So the start is going to continue till end. We'll calculate the mid over here. Also note that this is the data type is of long type. So instead of int, we can take this as long. We'll change all of these to long data type. Then we'll also calculate the square, which is equal to mid into mid. Then we'll start with the if conditions. If square is exactly equal to the number that we're looking for, we'll return mid, which will be the potential square root. Else if square is lesser than x, now in this case we have to store the value of somewhere because we need the floor of this. We'll also define another variable int answer to 0 and we are going to store the mid value over here first and then we'll manipulate the value of start. Otherwise we are going to just decrement end equal to mid minus 1. Outside of the loop we have to return answer. That's all about it. Let's compile and run. Lossy conversion from long to int. Okay, so I think this needs to be long. Even this has to be long data type. Okay, now we'll submit. So yeah, with that all the test cases have passed and that's all about this question, how to find a square root of a number using binary search algorithm. Stay tuned for more such questions on the binary search algorithm. Hope you guys have enjoyed the session for today. Do let us know in the comments below if you guys have any questions or doubts or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people, and if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.